So we've spent some time looking at slope-intercept form. In this equation, we're going to look at a different form of an equation of a line, still an equation of a line. It's called point-slope form. So it is, when we're writing equations of a line in slope-intercept form, you have to know the slope and you have to know the y-intercept in order to use that equation. But sometimes you don't know the y-intercept. And so when that happens, you can use the point-slope form. All right. So basically, this point-slope form comes from the slope formula. So we found out earlier that the slope formula was this: m equals yt minus y1 over xt minus x1. Okay, so if we write m as a fraction, m over 1, and then we look at this as kind of a proportion, then we know that this times this is equal to this times this. It's kind of like you're doing that butterfly thing. So m times xt minus x1 is the same thing as 1 times yt minus y1. So if we rearrange this formula, what we've gotten is a point-slope form. All right, so that's kind of where it comes from. And it's useful when you know the slope and when you know just a point on the line. Any point doesn't have to be the y-intercept. Okay, so here's an example. Write the equation of the line that passes through this point, negative t3, and has a slope of 4. So this is the form we're going to be using. Now, it's slightly different than just the rearranged slope because you want to leave y and x in there because you're writing the equation, right? So we have y minus, and then if you look at this point, negative 2, 3. So if this is the point, negative 2, 3, then the x1, y1 would be 3. So that's going to replace y1. And x1 is going to be negative 2. So x minus x1 would be negative 2. And then m is the slope, which they tell me in the problem is 4. Okay, so after you plug it into this formula, then you're just simplifying it, basically. So I have y minus 3 on this side. This side, I have 4 in parentheses. I have x minus a negative 2. So I'm going to rewrite that. Keep, change. So that's x plus 2. The next thing I need to do is get rid of my parentheses, which if I have a number outside the parentheses, that's telling me to multiply. And if I'm multiplying, if there's more than one thing inside the parentheses, then that needs to get distributed. I'm multiplying by both of these. So I'm doing 4 times x and I'm doing 4 times 2. Okay, so 4 times x is 4x. 4 times 2 is 8, and I keep the plus sign. All right, then I want to go ahead and solve this for y because I'm going to leave my equation in slope-intercept form. Even though I'm starting from this, I'm going to leave it in slope-intercept because that's always easiest to graph from. All right, so I solved this for y, so that means I have to get rid of the minus 3, which means I'm adding 3. I'm going to add it to this 8 over here. So this goes away. This side is just y. 4x doesn't change, and then 8 plus 3 is 11. So this is plus 11. So my equation now is 4x plus 11. Okay, so again, when I don't know the y-intercept, okay, and I just have a point and a slope, then I can use this form instead to find the equation of the line. Okay, this formula also works when you know 2 points, okay? And the reason it works is because you can use the slope formula to find the slope, and then you have a point and a slope. All right, so since the slope formula is already written for me, I'm just going to pick one of these. So this is x1, y1. Let's call this one x2, y2. So y2 is 9, y1 is 1, and then x2 is negative 2. And x1 is 8. All right, so that becomes 9 minus 1, which is 8. And then on bottom, I'm going to rewrite that. So negative 2 plus negative 8. So that gives me 8 over negative 10, which simplifies to negative 4/5. Okay, so now I have my slope, negative 4/5. All right, and so once I have a slope and I have a point, then I can use this form, the point-slope form, to write the equation. Again, it really doesn't matter which point I use. I just need to pick one. So I'm going to use, since I've already used x1, y1 with 8, 1, that's what I'm going to use again here. And then I'm going to use my slope, negative 4/5. Oops, sorry about my dogs. So y minus y1, y1 is 1. The slope, m is the slope, so negative 4/5. And then x minus x1 would be 8. Okay, then you want to distribute next. So this is y minus 1. I'm going to multiply times x. I'm going to multiply times 8. So this is negative 4/5 x. and then a negative 4/5. I'm going to go ahead and rewrite this as plus a negative 8. So keep, change, change. And then a negative 4 times a negative, think of this as negative 8 over 1, and just multiply the fractions. So negative 4 plus negative times negative 8 is a positive 32. 5 times 1 is 5. 32 over 5. All right, so the last thing you want to do is solve it for y. Okay, so I need to add 1 to both sides. Oops, add 1 to both sides. Adding 1 over here. All right, so this is not a pretty equation. Over here I get y. This is negative 4/5 x. Okay, but then here I need to add 32/5 plus 1. If I'm going to add fractions, I'm going to need to find a common denominator. So instead of 1, I need the denominator to be 5. So I multiply by 5 here. I have to multiply by 5 on top. So I'm adding 5/5 to 32/5. That gives me 37/5. So here's my equation. And it is okay to leave this fraction improper as long as it's simplified. All right, so again, not a pretty equation, but it's correct. If you were graphing it, you probably would go ahead and make this a mixed number or go ahead and divide it. But since we're just writing an equation, we're going to leave it like that. All right, let's look at a few more examples. Write an equation in point-slope form and slope-intercept form for each line. All right, so I've got the point, I've got the slope, so I'm using this equation. Y minus y1 equals the slope times x minus x1. Okay, this is my x1, y1, and this is my slope. This is my m. All right, so you're just replacing y1 with 9, so y minus 9. Replacing m with negative 2. X minus x1, so x stays there. x1 changes to 1. Okay, and then you distribute it. So negative 2 times x and negative 2 times negative 1. So y minus 9. Negative 2 times x is negative 2x. I can go ahead and rewrite this as plus a negative 1. So negative 2 times negative 1 is a positive 2. And then solve for y. So I need to add 9 to both sides. So y equals negative 2x. 2 plus 9 is 11. That's my final answer. Right? I'm not adding 11 plus 2x because they aren't the same, right? This one doesn't have an x, so I can't add it. All right, try another one. You've got a point and a slope, so you can go straight to your point-slope form. Y minus y1 equals the slope times x minus x1. So this is going to be my x1, this is my y1, and this is my slope. Okay, so y is part of your equation. y1 is negative 5, so y minus negative 5. The slope is 3/4. X is part of your formula, minus x1, so minus a negative 4. Okay, so I'm going to simplify some of these negatives just so they don't get lost. So y minus negative 5 becomes y plus positive 5, 3/4. X, keep, change, so x plus 4. And then think of this as 4 over 1 because you're going to distribute the 3/4. So y plus 5. 3/4 times x is 3/4 x. 3/4 times 4 over 1. So 3 over 4, top times the top is 12. 4 times 1, bottom times the bottom is 4. Now this time, this is a little easier because 12/4 will simplify. So I still have y plus 5 equals 3/4 x plus 3. And then I can solve by subtracting 5. Okay, so on this side, I have y. This is 3/4 x. And then 3, positive 3 minus 5 is negative 2. So I have plus a negative 2, or I can just write that as minus 2. So this becomes y equals 3/4 x minus 2. Okay, so let me know if that confuses you. But basically, you're just plugging in the point and then simplifying. Okay, so there are lots of little details that you have to pay attention to. So make sure you catch your signs. Okay, make sure you distribute times both the x and the constant. Okay, simplify it if you can, and then move to solve for y. Okay, in the next two examples, you're given 2 points. So when that happens, you can't jump straight to the point-slope form. You have to find the slope first. All right, so this is x1, y1, and this is x2, y2. And my slope starts with y2 minus y1. So y2 minus y1, x2 minus x1. So that would be 2 minus negative 6 over negative 1 minus 3. Okay, if I rewrite that as 2 plus 6 and negative 1 plus negative 3, I get 8 over negative 4, which simplifies to negative 2. All right, so keep, change, change, keep, change, change is all I've done there. All right, so now I can use the point slope form. Y minus y1 equals the slope times x minus x1. All right, y stays as the formula. Y1 I said is negative 6. The slope is negative 2. X is part of the formula. X1 is 3. Okay, now simplify it. Y minus negative 6 becomes y plus 6. If I go ahead and distribute here, negative 2 and negative 3. I'm going to go ahead and rewrite this as plus a negative 3 here so that when I distribute it, I won't lose my sign. So negative 2x plus a negative 2 times a negative 3 is a positive 6. All right, go ahead and subtract 6 from both sides. Those go away. This is y equals negative 2x. Over here, these cancel out too. So this time, my equation is just y equals negative 2x. All right, and the next one, same thing is what I'm going to start with. I'm going to start by finding the slope. So y2 minus y1. And let's see, x2 minus x1. All right, so if y2 is over here, negative 4, and y1 is 4. And over here, x2 is 5, and y2, this is x2, y2, and this is x1, y1. Okay, so y2 minus 4, and then x2 minus, yeah, this is right. Okay, so negative 4 plus a negative 4, and then on bottom, 5 minus 3 is 2, so that's negative 8 over 2, which simplifies to negative 4. Right, and then if you plug in your formula, y minus y1 equals the slope times x minus x1. And I have y minus y1 is 4, the slope is negative 4, x is part of your equation, x1 is 3. And then simplify it. Y minus 4, distribute. Again, I'm going to rewrite this as plus a negative 3. Keep, change, change. Then I'm going to distribute the negative 4. So negative 4x, negative 4 times a negative 3 is a positive 12. Okay, solve for y by adding the 4. So this goes away. This is y, negative 4x plus 16. Okay, and that's your final equation. All right, that's all for point slope. Again, it works for when you have the slope and a point or when you have two slopes. All right, see you soon.